If left in a landfill, a glass bottle can take up to 1 million years to decompose. But if it enters the right recycling system, it only needs a few weeks to be reborn in a new form. That durability, which may seem inconvenient, becomes an advantage of materials science. Glass can be recycled in a 100% material cycle and almost not lose quality if it is properly sorted and contaminants are well removed. Behind that is a tightly operated regeneration industry. From the collection point, glass enters the factory, passing through screening, crushing, metal separation, optical sorting, melting, and automated forming. Today, join Factron Process as we enter the factory to follow glass recycling, where fragments that seem worthless are turned into new bottles and jars. The glass recycling process begins with collection, where used bottles and jars are separated from the household waste stream and brought to specialized processing points. In many European countries, glass packaging is organized as a separate material stream, with collection networks, deposit policies, and industrial sorting facilities. Thanks to this system, the EU reached a glass packaging collection rate for recycling of 80.8% in 1 year, with more than 12 million tons of glass collected. When clean cullet returns to the furnace at a sufficiently high ratio, the production line can help reduce 20% of emissions and save up to 30% of energy consumption. This glass source can come from recycling bins on the street, restaurants, hotels, bars, supermarkets, beverage factories, or municipal waste sorting centers. At the first stage, glass is still not a clean raw material. It often comes with paper labels, metal caps, plastic stoppers, glue, plastic bags, dirt, and even household waste that has been thrown in by mistake. Some bottles still keep their original shape, some have already cracked, and there are also glass fragments mixed with different colors. After being collected, old glass is transported by specialized trucks to the recycling plant. At the receiving area, each truck container is lifted, then tons of bottles and jars are poured onto the storage floor or into the feeding hopper. To consumers, this may only be post-use waste. But to the factory, it is a valuable secondary raw material, and the first step that determines the cleanliness of the entire production line behind it. Before being crushed and sent into the furnace, old glass must go through an important stage: initial receiving and screening. The factory needs to accurately control what is inside this mixed material stream, because not everything that comes with old bottles and jars can become new glass. Bottle caps, plastic bags, paper labels, stones, ceramics, light bulbs, heat-resistant glass, or crystal glass can all cause defects in the final product. Just one small piece of ceramic entering the furnace may not melt completely, then create a hard defect particle inside the new bottle. These contaminants not only reduce glass quality, but can also cause an entire batch of products to be rejected. Therefore, on the input conveyor belt, workers and machines first remove large contaminants together. Objects that are easy to see are picked out manually, while screening systems, magnets, and eddy current equipment continue to separate metals, such as steel caps, aluminum rings, or small metal wires from the glass stream. After this step, the glass stream has removed most large contaminants and is stable enough to move to crushing. But it still keeps its original shape, has uneven sizes, and cannot go straight into the furnace. The bottles and jars that once had clear shapes are now fed into a crusher. In just a few seconds, they break into small, sharp-edged pieces called cullet, recycled glass fragments. The factory does not crush them randomly. If the pieces are too large, they are difficult to clean and difficult to melt evenly in the furnace. If they are too small, they create dust, cause material loss, and increase the load on the filtration system. Therefore, cullet continues to pass through vibrating screens to separate sizes. Pieces that are too large return to the crusher, while standard-sized pieces continue along the production line. At this stage, the air extraction system can continue to remove paper labels, fine dust, light plastic pieces, or remaining organic materials. At this point, water bottles, wine bottles, or food jars have completely lost their old shapes. They become a new industrial raw material. But the cullet still needs to be sorted by color and checked more carefully before entering the furnace. By this stage, the cullet has been crushed, screened by size, and cleared of most large contaminants. Before returning to the furnace, however, it must still pass through optical sorting. On a high-speed conveyor, cameras and sensors separate the glass by color: clear, green, amber, or mixed. Even a small amount of incorrectly colored glass can affect the color of an entire production batch. When an unsuitable piece is detected, compressed air nozzles eject it into a separate stream. The sensors also remove ceramics, porcelain, stones, and heat-resistant glass, materials that may not melt completely in the furnace. This process leaves the cullet cleaner, more uniform, and ready for mixing and melting. Clean cullet is weighed and mixed with silica sand, soda ash, and limestone. The amount of cullet depends on the glass color, material cleanliness, and final product requirements. Because cullet melts more easily than raw minerals, using more of it helps save energy. The mixture is then fed into the furnace and transformed into molten glass. Inside the furnace, the temperature can exceed 1,400 degrees Celsius. Cullet, silica sand, soda ash, and limestone gradually soften, blend together, and then turn into a glowing orange-red stream of molten glass. This material stream is thick, heavy, and glows like artificial lava. A piece of ceramic that has not been removed may not melt. A little remaining metal can change the color. A small amount of organic contaminant can create air bubbles. In other words, the furnace does not forgive carelessness. The quality of a new bottle does not begin at the forming stage, but from every previous step of sorting, cleaning, and inspection. When the glass reaches a stable molten state, it still cannot become a bottle immediately. The material stream needs to be homogenized, have bubbles reduced, and have its temperature adjusted before entering the forming area. And that is when the glass drops appear. From the furnace channel, molten glass is released as a continuous stream, then cut into separate drops called gobs. Each gob has a weight calculated according to the capacity and design of the product. For small bottles, each drop may weigh only a few dozen grams. For large bottles or thick jars, the weight can reach several hundred grams. After that, each gob falls into a heat-resistant steel mold. Compressed air is blown inside, pressing the molten glass against the mold walls to create the initial shape. Next, the bottle is transferred to the finishing mold, where another stream of compressed air continues to expand the glass, accurately forming the body, shoulder, neck, mouth, and base of the bottle. The entire process takes only a few seconds, but it requires very high synchronization between the glass stream, the gob cutting knife, the mold, the pneumatic valves, and the conveyor belt. In modern production lines, one forming machine can produce hundreds of bottles per minute. At this point, the pieces of glass that once lay in the trash have taken on a new form, but the product that has just left the mold is still very hot and contains a lot of internal stress. Therefore, it must go through an annealing layer for controlled cooling. New bottles are sent into the annealing layer to cool down slowly. Why does this have to be done slowly? Because if glass cools too quickly, it will create internal stress. The outside may look perfect, but inside there are invisible points of tension. With only a light impact, a temperature change, or pressure during transportation, the bottle can crack or break. Inside the annealing layer, the temperature is controlled by zones. The bottles move slowly from the hot zone to the cooler zone, so the internal structure becomes more stable. This is a quiet step, but it determines the true strength of the product. And when the bottle leaves the annealing layer, the factory still does not let it leave the production line. Before reaching consumers, every bottle must enter an almost uncompromising inspection system. Thousands of new bottles and jars run through an automated inspection system. Cameras inspect the bottle mouth, body, and base. Sensors check thickness, air bubbles, cracks, deformation, internal contaminants, and shape deviations. Tiny crack? Rejected. An uneven bottle mouth? Rejected. An air bubble in a dangerous position? Rejected. Defective products are not considered final waste. They are crushed again, become internal cullet, and return to the beginning of the process. That is the interesting thing about a glass factory. Even production defects can be regenerated. Qualified bottles are lined up, gathered onto pallets, wrapped with protective film, and sent to beverage, food, cosmetics, or pharmaceutical factories. As for the input cullet processing stage, recycling reports in Europe show that 93% of the material entering cullet treatment facilities has been effectively recycled. This figure shows that the quality of collection, sorting, and initial processing directly determines the ability of glass to return to the furnace. After being formed, annealed, quality inspected, and packaged, qualified glass bottles are transferred to a beverage factory to begin a new life cycle. A familiar example is a Coca-Cola bottling line using glass bottles, where the recycled material has returned as a complete package, ready to enter a new consumption cycle. Before filling, the bottles are thoroughly rinsed with high-pressure hot water and steam to remove dust, bacteria, or contaminants left from transportation. Then they move on a high-speed conveyor belt to the filling station. Here, the automated system pumps Coca-Cola into each bottle with precise volume, while pressure is controlled to keep the CO2 level and the characteristic fizz of carbonated soft drinks stable. Immediately after filling, the bottle is sent to the capping area. The metal cap is pressed tightly onto the bottle mouth, then sensors check the seal to ensure there is no leakage. At the end of the line, high-speed cameras continue to inspect the fill level, labels, overall shape, and any possible defects. Only qualified bottles are packed into cartons, stacked on pallets, and transferred to the warehouse, ready to be distributed to stores. After being filled, capped, labeled, and distributed, glass bottles return to supermarkets, restaurants, eateries, and consumers' hands. A soft drink bottle, a sauce jar, or a beer bottle may contain part of the material that was once fragments from hundreds, even thousands of other bottles and jars. This is the greatest strength of glass. It does not need to be downgraded after each recycling cycle. If it is sorted properly, cleaned properly, and melted properly, old glass can return as new glass packaging, preserving almost its original value. And when its use life ends, that bottle can return to the collection point, go back to the factory, pass through the crusher, the furnace, and the forming mold once again. A material breaks apart, but it does not disappear. So, we have now followed the complete journey of glass recycling, from discarded bottles and jars to their return to everyday life in an entirely new form. It all begins at collection points, where glass containers are separated from household waste, gathered, and transported to a recycling plant. From there, they enter a carefully organized regeneration line, where even a small contaminant can affect the quality of the final product. The old bottles and jars are first screened to remove metal caps, paper labels, plastics, stones, ceramics, and other unsuitable materials. They are then crushed into cullet, screened by size, and sent through optical sorting systems. Cameras, color sensors, and compressed air nozzles work together to separate the glass by color and remove fragments that could create defects inside the furnace. The clean cullet is weighed, mixed with silica sand, soda ash, and limestone, and then fed into a furnace operating at extremely high temperatures. Here, fragments that once belonged to many different containers lose their original forms, merge together, and become a single stream of molten glass. But the journey is still far from complete. The molten glass is cut into individual drops called gobs, delivered into molds, and shaped with compressed air. In only a few seconds, a shapeless material becomes a new bottle or jar, complete with a body, shoulder, neck, mouth, and base. The newly formed containers then pass through an annealing layer, where they are cooled gradually to release internal stress and develop the strength required for transportation and use. Next comes an inspection system that is almost unforgiving. Cameras and sensors examine every container for cracks, bubbles, deformation, uneven thickness, and remaining contaminants. Products that fail inspection are crushed again and returned to the production line as internal cullet. Even manufacturing defects do not necessarily have to become permanent waste. The bottles that pass inspection are packaged and transported to beverage, food, cosmetics, or pharmaceutical factories. There they are cleaned, filled, capped, labeled, and distributed back to supermarkets, restaurants, stores, and consumers. A newly filled soft drink bottle may contain material that once belonged to hundreds or even thousands of previously used glass containers. That is the special strength of glass. Unlike many materials that lose quality after each recycling cycle, glass can return as new glass packaging if it is properly sorted, cleaned, and melted. A bottle may shatter into dozens of pieces, but the value of the material inside it does not have to end there. Once its new period of use is over, that same bottle can return to a collection point, travel back to the factory, and pass through the crusher, sensors, furnace, and forming molds once again. The cycle continues, turning what was once considered waste into raw material for another round of production. Behind every glass bottle sitting on a store shelf is more than sand, heat, and machinery. It is the result of collection systems, sorting technology, energy, forming equipment, and multiple stages of quality control working together. If even one link in that chain is missing, a piece of glass may end its journey in a landfill. But when every stage is carried out correctly, the material can continue through many different life cycles. And that is what makes this journey so remarkable. Glass may break, change shape, and lose its original purpose, but it does not necessarily disappear. In an effective recycling system, the end of one bottle becomes the beginning of the next. If you found this journey interesting, don't forget to like, subscribe, and turn on the notification bell to continue exploring more industrial stories with Factron Process.